Hi, so welcome to the another session of Internet of Things here. So in this class of IoT, we will discuss about the IPv6 over low power personal area network. So we have been studying here about various IoT enabling technologies. Now, next one which we have here is IPv6, that is Internet Protocol version 6 over your low power network, that is your personal area network here. So, first of all, we are using here IPv6 for your Internet of Things here. Now, we know that this Internet protocol has revolutionized the use of Internet around us. But the previous version, which is your IPv4. Now, this protocol version is fully occupied. That means the addresses here are exhausted, but with the help of certain techniques like network address translation, this has been extended. Now, in the Internet of Things, we know that every smart device is supposed to connect it to the internet. So we need a billion of addresses. So that's why we're using here IPv6 for addressing of the devices in the IoT system here. So that means it will provide us a resourceful addresses for connecting various devices. So we have IPv6 here, but this IPv6 over low power personal area network is a parallel technique, or we can say that a constrained version of IPv6 for Internet of Things, because we have a constrained environment here. That means we have low power devices and lossy network. So to support these devices, this technique here has been evolved, which would support the IoT requirements here. So this IPv6 LoWPAN implies that every device should be, or we can say that every device should be connected to the internet with the help of IPv6. So this provides the connection of, we can say that all the smart devices are IP enabled. Now, why this technique? Because this technique is supposed to here connect all these devices to the cloud infrastructure. It supports the mesh networking, and the most important thing, that the low power devices which has limited capacity. So that means these devices which can participate in Internet of Things, they should be here IP enabled. So this is the fundamental here for your IPv6 low power personal area network, that every device which is supporting here mesh topology, low powered and limited processing capability, that would be here IP enabled. Another advantage of using this technology is that now one such kind of network can be connected to another IP network without any gateways or proxies here. And moreover, the IP network here supports the use of existing infrastructure. And this technique here will come with the advantage of your IPv6 security, authentication, and encryption. Now, after that, we will study about here the architecture for your IPv6 over low power personal area network. Now, we will have the internet web here. It means this is your IPv6 here. and the different servers with it. Router. These are basically your IPv6 routers. And these routers are here connected to various devices. Now, here we will have your now this is here your IPv6 internet, and this is your low power personal area network enabled with the IPv6 technology. So now this is your network here. So this is regarded here your the scenario for your IPv6 network and a mesh low power personal area network enabling IPv6 technology here. This is IPv6. Now we can see here that this network, in order to get connected to internet, is using this edge router. So that means this uses this stub network in order to enable the connectivity between the various devices in this low power network and the internet web. So the uplink, or we can say that uplink to the internet from these devices is enabled through these routers. Now these routers are basically your IPv6 routers. Now many devices can here be connected to these routers, and then they will be forwarding the information here to this web infrastructure. Now this your IPv6 low power personal area network is connected to this internet here using this edge router. So that means this is here the core element for enabling the connectivity between this infrastructure and your low powered network here. So data will be, the information will be exchanged here between these two scenarios. So that here takes place with the help of this edge router. So we can say that this edge router is here responsible for exchanging the information between the devices in this low power network and the internet. Now, in this network, we will have these IPv6 enabled devices. Now, this network has hosts and your routers. Now, routers are the elements which are responsible for forwarding the data to a required destination. So these elements here are capable of routing. Now next element which we have is simply the hosts. These are the nodes. That means these are the devices which are connected to the router so that they can forward this data to the edge router. Thus the edge router then forwards the data here to this web infrastructure. Now here this communication will take place outside the network also, but these routers enable the exchange of information inside this low powered network also. That means these host devices can also communicate with each other with the help of these routers here. So these are the two elements here, and this is the core element, this edge router, which is connecting your low powered personal area network and your IPv6 here. Now this network, this low power network here can be connected to some another low power network just with the help of these simple edge routers here. So here, these will be your small devices like your sensors and your actuators and other smart devices, which will be communicating here with your internet with the help of your IPv6 and this edge router enabled for this connectivity here. So this is the infrastructure for your low powered personal area network. Now next topic which we will study here is the system protocol stack. Next is your system protocol stack here. Now we have certain communication models here like your OSI model, which is your open system interconnection model having seven layers. Then if you have a look at the Wi-Fi stack here, so it will also have its physical layer, its data link layer, and the network layer connecting it to the third party, that is your internet here. Then we have here the simplified protocol stack for your this technology, which is your IPv6 over low power personal area network. So for this, we'll start here. Now this IPv6 here will be running over like your Zigbee devices, that is your IEEE 802.15.4 standard. So for physical layers, we have here this, then this is your data link layer. We're using here the MAC layer, which is the sub layer. Then now this is the protocol stack here. Here we have now this protocol stack simplifies many problems as this provide here an adaptation layer for your low powered personal area network. That means it will be providing here the connectivity between this data link layer, that means the stack which is having here data link layer, and the IPv6, that means it is enabling here the communication between this network and these Zigbee devices over here. So this is providing the adaptation of data from this point to this point and from your this network to the sensor devices here. So first of all, we have here the IEEE 802.15.4, which is your physical layer here. So that means it is consisting here of certain devices like the sensors, actuators, making it as a wireless embedded internet. Now this is here concerned with the real-time transmission of your data, that what are the electrical mechanical specifications here of the various devices and how they're communicating with the next gateway here. So it has improved versions like your IEEE 802.G, so which basically provides an extension of the frequency that is up to 1 more gigahertz here, and another standard which provides time slot channel hopping here. So this is just the physical layer which consists of actually the devices here. Now after that, the next one is your data link layer. So this data link layer here provides a reliable communication by correcting the errors or making the raw data from this layer into more appropriate manner. So this basically implements here or uses this MAC layer, which is your media access control, so which basically is used to access the channel here. So this is using here or provides here CSMA CA mechanism, which is your carrier sense multiple access with collision avoidance principle. So we have studied these here in our ZigBee specification. So this is your physical layer and data link. Now after that we have here network layer. So network layer is responsible for addressing and routing the data across the network. That means the stub net addresses will be provided here. But in between there, we have this IPv6 adaptation layer, especially for these kinds of networks, so that it provides the transfer of this data across these censored nodes here. Now, after that, the next one which we have here is your transport layer. So transport layer enables the communication between the various sessions which are enabled or sessions here between the various applications. So this particular layer, what I do here in IoT is that it provides various applications that could be carried over one particular device. That means it is responsible for providing different channels for different applications. Now it uses protocols like your TCP and your UDP, like your transmission control protocol and user datagram protocol. So some of the protocols just support UDP, and sometimes like TCP has larger overhead. So mostly UDP is here used for your Internet of Things here. Now after that we have the application layer. It means to the user interface. So most of the applications here are like your based on HTTP, which uses like your text based languages, but this is this HTTP is not an optimum choice here for your Internet of Things. So for such kind of constrained networks in which we have some constrained nodes like smaller device employing smaller power and requiring low throughput. So some lighter versions of protocols have been developed for your Internet of Things like your CORE, which is a constrained application protocol, and like your MQTT. So this is here the system protocol stack for this low power devices, starting from your physical layer to this application layer here. So this IPv6 over low power personal area network is a driving key driver here for this IoT system, and that means it implies that every small device should be able to get connected to the network. That means it should be able to connect to the web infrastructure here. So in this particular class of IoT, we have just studied here about the IPv6 standard version for your low power personal area networks, its architecture and the system protocol stack. So we will be studying more about Internet of Things in our next sessions. Thank you so much.